Welcome to the Human of Reliability podcast. I am Sylvain Kalache, head of the Rootly AI Lab and your host for today. In this episode, we are joined by Galileo head of content and developer awareness, Conor Brondsdon. Let's dive in. As I was telling you, Conor was at SRECon in Europe, and obviously observability and monitoring was a big topic. The Institute for Ethical AI and Machine Learning survey actually found that only 50% of companies are today doing monitoring on their model.
I believe that.
And, which, is a very surprising number. But yeah, let's dive into it. Like, when you want to push, this LLM-powered application in production, like, what are the pitfalls that teams are generally facing?
Yeah, I mean, there are plenty of pitfalls and different failure modes we can go into, but it depends on the type of application you're creating. I think a lot of enterprises in particular are still creating reg systems. We're seeing agents really take off as well, but in a lot of ways, what we're trying to do is increase the response quality of our AI systems so that they're more accurate to the domain data that we'd like to feed it, and lower the latency so that it's more useful in production at times, and ensure that there are great guardrails so that it doesn't break out and hallucinate or do improper actions. And all of that takes infrastructure work. I think it's easy for us to say, AI is so magical, and it is in many ways. It's just going to solve this problem for us, but you still have to set it up for success. You can't think of it as an employee who's been at your company for 50 years and knows everything and can take responsibility. You have to think of it as someone who's very smart, who has a lot of background information, but is new and needs training and needs support on understanding your tribal knowledge, getting into your document corpus, and ensuring they take the right actions. So as long as you take that approach and you do the work to set AI up for success, just like you would with any junior employee, I think there are incredible gains to be had. But if you're not observing your AI systems, you are definitely not setting yourself up for success, because you will have to, at a minimum, while you're working on the system, do some root cause analysis of, like, why is it giving this answer when it is incorrect for some reason? And if you don't have that observability in place, if you don't have monitoring systems in place, you can't even begin to truly unpack that, because if you're just throwing a question to an LLM, it's kind of a black box. And so having those observability systems in place is crucial to actually understand the problem and begin to fix it. So yeah, I think I'm really glad that there is this conversation happening, and there are a variety of ways to approach this, which I'm sure we're going to dig into. But bottom line is, whether you're doing full, test evaluation driven development or not, you have to do work to actually understand the outputs you're getting. It's not going to be a simple binary yes, no.
Yeah, there is this old saying in the reliability world where we say that you can only fix something if you can measure it, right?
Yes.
Otherwise, you don't know if it's broken. If you do something to it, you don't know if it's going to make it better or worse. But what is interesting, you spoke about success of, request or accuracy. All of these terms in the old, deterministic world, like web workload, was kind of simple. Like, if we take, we oversimplify, like, you could look at a web application and look and understand the health by looking at the number of 200s. This is good. 400 is like not great, but okay, and then 500 is like the bad, right area.
Yeah.
But when we look at workloads and the output generated by LLMs, it's not always that straightforward. Let's say that your application is supposed to generate summary of news. How do you know that the summaries that are generated today are better or worse than the one that were generated yesterday, right? There is no straight answer, right? So how can you go about navigating this change?
So the approach we take is to use out-of-the-box metrics as you're getting started to understand and evaluate whether these answers are being successful, and then customize those metrics to your system over time. So, for example, let's say you have, a RAG-based chatbot that maybe has some agentic tools on top of it. For the initial RAG system, which essentially just for context, like we've ingested domain data, we've put it into, let's say, a vector database, so it's searchable by that LLM. When a user puts a query in, the system will then go through that database, find relevant contextual information, augment the initial query with that information. So the LLM's getting essentially an injection of direct context right at the point in time of answer to help it kind of jog its memory and give it key information. And then we're generating a response based off of that. So that's kind of the very typical demo that you've probably seen over the last couple of years. There's many variations of this. And let's say maybe it can use some agentic tools and actually search the internet to enhance that. Anyone who's used Claude, for example, has seen that opportunity with Claude projects, just at a very simple level where you can say, oh, okay, like, let me add some documents to the information corpus of this project, and then it can also search the internet as well. Let me ask it to do these things together to respond to a question, and it will enhance their question's response. Now, if I was instrumenting that system, what I would be looking at is the model's output sticking to the given context? Because we want to ensure it adheres to that. So, we have a RAG evaluation metric called context adherence. You can use out of the box with Galileo that we've built for that. I'd be looking at, hey, is the model actually fully answering the question? Because, hey, I've done this in interviews before, and models have certainly done this where maybe you give me a 2-part question and I really focus on the first part, and the second part, I didn't quite complete it. So let's look at the completeness. And then I looked at, if I have access to the system backend, I'm also going to evaluate and decide whether or not the chunks that were actually pulled in as far as contextual information to feed the model for that response, were those actually relevant? Were they attributed to the model's response, or were they somehow off base? Because that could tell you, hey, there's a problem in my retrieval of all this domain information or the indexing of this domain information in the system. So chunk attribution. And then I would look at, the utilization of those chunks as well with chunk utilization. But as you start getting to more complex systems, I may look at things beyond simple, RAG-based metrics. I may look at some agentic ones. Like one example of these is, action advancement. Did the action the agent takes, as you look at this graph of agent actions, actually advance the goals that was set out by the user? Is it making meaningful progress, or was this a sidebar? And we see this is really important in agentic systems because of the concepts of reinforcement learning in AI. And the idea behind reinforcement learning is basically you try 15 different things at once, 100 different things at once. And essentially anything that gets the right answer off this pre-established ground truth, you just essentially upvote the weights of all of the different actions that were taken within those different factual paths that got there. With an agentic system, though, we want to get much more clear on this because, in that traditional RL example, it's a great way to help large models improve over time. But in a specific instance, it actually doesn't provide you great insight on, did the actions that were taken to solve this problem really get you all the way there? And so with an agentic system where we have better observability and also typically don't have as many instances solving these problems all at once together to evaluate off of, we can actually go in and say, oh, let's look at action by action as you got to this answer, as you showed your work, look at your chain of thought, did these individual routes actually help you get there, which is more like what a human would typically do as far as learning. Instead of saying, oh, I got the answer in the end, it's all fine. Now, that's not to be said that we don't also do that sometimes. I've certainly spent a year on something and been like, this is part of my learning process. But typically, we're going to try to break that down more. And I think that's what I really see the industry trying to do is say, as we get better at monitoring, as we get better at observing, as we get better at evaluating, let's get more granular about what's actually working versus just saying, okay, we generally got the right directions, kind of push things that way. So we're trying to get more specific and clear.
What's funny with what you just shared is that some of the strategies that we used are really kind of, they are really not machine centric. Like the way that as an industry used to do monitoring was very binary, right? Like we're like assessing machines, right? Like it works, it does not. Then, you have signal where when it does not work, it's not 1-0, but it's a level that can more like a gradient. It's more like human-like. Because at the end of the day, right, the system it's natural language. And, I think there are like some fun parallels to be made between the ways that we assess humans and the ways that we assess now this type of workload when you mention the completeness right? Of perhaps you are in an interview and you only know part of the answer,
Totally.
right? Our politicians are really good at doing this, answering the.
If I filibuster any of
right?
Sylvain's questions during this conversation, you know what's happening. So yeah.
Right. And actually, again, at SRECon in the US in 2025, Brandon Burns gave a talk. He's working with Microsoft. And he said that the Azure team, one of the way that they are judging the LLM outputs is that they are asking Microsoft employees to provide like a thumbs up,
Yep.
thumbs down feedback. And when he said that, like people like just lost, like very nervously, like because people are like, what the heck? Like this cannot be, this is not a serious metric, but it is, right? And so again, I think like there is a wake up call that needs to happen among reliability and infrastructure folks and some of what we've been doing for decades still applies, but there is really a new breed, of monitoring of observability that Galileo in part is leading, that they need to integrate in the tool that they are using, right?
Yeah, I'll say like human input, I think, is still an important part of these processes. We can't fully offload them to machines. Like it's great that you can generate a synthetic data set. You can do it in Galileo, in fact, to help you establish ground truth and identify what's going to be successful so you can train your system before production. But I think it's crucial for us to enable human feedback, whether that's continual human data labeling across a variety of different situations, or whether it's what we do when you don't have access to quite as few SMEs as maybe Microsoft does. You can say, okay, like let's just provide feedback on a few different examples here. And you basically few shot that and provide it back to the model so that this limited number of examples gets extrapolated across the rest. And we see that continuous learning through human feedback, that auto tuning of evaluators and evaluation metrics provides quite a bit of benefit just in that approach. So I think there's room for machine approaches, there's room for human approaches, and they should really be working in concert. And I think anyone who has tried to, let's say, write with an LLM, for example, like they can do a good job at getting you to a draft. But if you want to have a truly great piece of writing, you're going to need human editing. You're going to need human feedback in there. And it's very much the same as you look at these machine systems as well. Like there is, as we've said, magic to this non-determinism. There is incredible opportunity. If you're using an AI coding agent to do repeatable tasks that take a lot of time, like there's a lot of upside there. But as you get more novel, as you get to something where you need more elegance, it is important to bring in human feedback and human expertise to guide it. And I really think what we're doing is we are, I guess, disaggregating ourselves away from some of the busy work over time. And hopefully what that's going to mean, if we do this right, is we get to do more work on strategy. We get to do more work on architecture. We get to do more work on deep thinking. And that is what I'm really excited about with these agents, with these AI systems. And I think there's a huge opportunity to get there. But part of unlocking that, as you've said, is effective monitoring, effective evaluations, and guardrailing too. I think it's important to remember that, we can do all we want to monitor and dev, but if we're not actually effectively stopping bad actions in production, then we have a major gap, particularly as we look at like regulated industries like banks, for example. We work with several large banks and financial institutions because we add guardrails on top of their systems where if a user is coming in and we can both use their authentication and then have an input guardrail to double check, hey, are they trying to do a prompt injection attack? And then you should have probably another guardrail on the other end where we say, hey, does this response from the model, is it leaking personally identified information? Is it correct? Is it really solving things? So, it's possible to do that now by using fine-tuned small language models that can actually work in basically real time. But there are huge latency challenges with these systems. There's accuracy challenges. There's cost challenges. I mean, like if you look at a simple RAG chatbot that's maybe being used for customer support, it's really easy for that cost to balloon over time. You've got your embedding model, which is pretty negligible cost, maybe like a hundredth of a cent. But then every time you are responding to a query, you have to retrieve the information. And maybe that's half a cent that you have to spend there on your self-hosted re-ranker, your vector database, the retrieval. And then you have the generation piece. Like, this starts to really add up over time. So I think there are major opportunities for software engineers who understand AI systems to spend a lot of time on optimizing them for latency, optimizing them for accuracy, improving those outputs, and optimizing them for cost. And I don't think, we've seen these like doom and gloom predictions, like software engineering is going away. It's not. We're just spending time on different problems and different types of infrastructure. And I would really look to data engineering, honestly, and say, like, look, I think we don't hear as much conversation about it because AI engineering is a hotter title. But, data engineering, observing data pipelines, understanding those systems, extremely relevant skills for machine learning that, if you understand them, give you a big leg up. And, one of the things you'll learn there is like, yeah, you have to have observability built in. If you're going to have a regulated environment, you're going to need some guardrails to make sure your LLM is actually giving accurate response to users. I mean, like maybe this will change in 10 years or 5. I'm not at a frontier lab. I don't truly know, but I think we have years of work to do to make these systems as effective as we want them to be. And this is why I think we see reports coming out from, Gartner saying, 40% of the AI projects they're seeing there are likely to fail by 2027. Why we see this, sensational headline somewhat, but I think directionally accurate that like MIT says, 95% of the AI projects they're studying aren't actually providing value. There is a big gap between a demo and a production ready enterprise AI system. And a lot of the work to make that effective is in testing, is in evaluating, is in observing that system, providing it feedback, setting up guardrails for negative outputs. There's still a lot of infrastructure work to do effective AI at scale. Like, yes, it's easy to spin up a demo. Yes, it's easier than ever for me to, vibe code a quick app, but getting that to something where I can have thousands, hundreds of thousands, millions of customers working with it, that takes another level of dedication. I think it's why you're seeing some big winners and then a lot of people who are surfing up the hype.
Yeah, the beauty of this LLM is that you can get a wow effect pretty much like instantly, right? It's very easy to put a demo and be like, wow. But then most of the work, as you just mentioned, will get into like putting in place these guardrails, making sure that the data is clean, annotated, and putting all the security and compliance, barrier in place. And all of this is more like often on the traditional more side of engineering, not as fun, but absolutely necessary.
It's so interesting though. Like I know it doesn't feel as fun, but the architectural side and it's I don't know. I think it's fascinating, but maybe that's just me.
Yeah, we all have a different point of view.
I'm a bad production line coder. So for me, I'm like, great, you're helping me solve a lot of the boilerplate so I can focus on the strategy and thought process where I actually have some strength. So I'm like, great, fantastic.
So, for the longest time with like code that provide like deterministic output, there is like this very popular test-driven development strategy. Yeah. What do you think is the equivalent when it comes to LLM?
Yeah, evaluation-driven development. Like I think it's an obvious next step in this, which is this methodology of building for AI and LLM-based applications that prioritizes continuous evaluation of the responses and everything happening in the system and measurement to guide the development process. It's very similar to test-driven development. You could argue it's the same, just a different term for LLMifying it. And I think it's a great approach to take. We're seeing more and more successful teams adopt it. We have companies like Airbnb that we work with that are doing that. And it really involves defining your success criteria, creating a set of evaluations or tests to measure that performance of the system against that criteria, and then using those results to iterate. And really, that's what I think most good software engineers spend a lot of time doing. And as they develop their systems, as they evolve these systems, we have to have guiding principles behind them. And for us, I mentioned it a bit earlier in the conversation, I think it's great to start with, we have, I get this point 30 plus out of the box metrics that you can provide and kind of get started there. And then what we really believe in is enabling customization. So customization whether it's like working with an LLM to create a custom metric based off of, agentic metrics that work for your system, or whether it's you defining it yourself with your subject matter experts, making that as easy as possible through code or through natural language. Because as AI systems get more and more complex, there is a need to customize what your evaluations look like, what your tests look like. And I'll say personally, I find this to be one of the areas where LLMs are extremely helpful. Where you've probably heard this concept of LLM as a judge, but I think many of us are writing our tests, or at least drafting our tests with LLMs. And that was one of the first things I spent time with it on. We're going to use a large language model, whether that's GPT-5 or 4.0 if we want to be a little cheaper, or Claude, or an open source model, or Gemini, whatever your model choice is. We can use it to evaluate the output of another AI model. So it's turtles all the way down, so to speak. So if we have, let's say I have a reg system. We talked a little bit about that earlier. It's pulling in domain data, it's getting user queries, and it's taking in our internal docs and it's saying, okay, like, let me help get our salesperson the right answer to what they should say in this situation. Okay. So the salesperson says, hey, I'm talking to someone about observability in banks. What do we have to provide them? What should we look for? Our reg system can then go, look for a bunch of document data and say, okay, here's some stuff about financial services. Maybe there's something relevant to banks. Maybe here's something on, model risk management, important regulations around banks. And then I'm going to, add that to the prompt, stuff that prompt, provide it to LM, generate response. Great. Here's the response. That response might be really accurate, but I don't necessarily know unless I get human feedback from the salesperson. But let's be real. If that salesperson was enough of an expert to be doing that, they probably aren't asking LLM. They probably just know where the document is. So, that may not be that helpful unless I have someone whose job it is to go kind of spot check some of these. Instead, what if I have another LLM? So, Gemini is doing that generation for me, but maybe I have an OpenAI model on top of that is spot checking that work. And it's saying, actually, I think this Gemini model missed something, or, hey, this looks like there was a hallucination, or, hey, did this adhere to the context? Maybe it didn't quite answer the question. Some of those metrics I brought up earlier. And you can use the LLM as a judge or reviewer or tester, however you want to think about whatever your framing is. But judge is the framework and terminology that has become popular. And basically, it will give us typically a couple sentence response and a score like 1 through 10 often based on how accurate is this? What do we think of this? And we then use that to give feedback to Gemini on its results. And you can set up a variety of different ways to have that feedback go in, and then that will over time improve the responses coming out of your model. And you can actually do this as not just a single judge as well. You can have a panel of judges. So if you're thinking, well, I don't think OpenAI is going to be accurate with their model 100% of the time. Maybe I have a Claude model, an open source Llama or DeepSeek model, and then I also have OpenAI doing it. They all do an evaluation, then we weight the scores differently. There are a variety of ways you can do it, and it's really helpful to improve the reliability and accuracy of AI systems over time. Though I will note, hey, look, again, we have opportunities to be for cost effectiveness, because if I have an LM judge that's running on every response in dev and maybe most responses in prod, that can start adding up if I'm getting hundreds of thousands, millions of queries a day. And this is where I think you see the kind of cost battles between open source models versus some of the proprietary frontier models be really interesting. And this is where there's a ton of infrastructure work, again, to be done to optimize. And for that reason, one of the things we've done is we have fine-tuned our Luna 2 family of small language models, which are designed to be lower latency, increased effectiveness after fine-tuning, and then much more cost-effective than an SLM as a judge. So that you can actually use small language models in production, and you can mix them in dev as well. But once you get to prod in particular, look, we can't have the latency of Claude going to think for a minute about something, and then come back with a response on, hey, was this an effective answer, before we block a negative output, right? If we have a guardrail there, the user shouldn't be sitting for a minute. They're not used to that, and it's a bad experience. Maybe they need that answer right away because they're on a sales call and they have to respond to something. So using small language models for that guardrailing within your system to help with your observability, and then basically blocking negative answers and providing feedback to improve the system, can reduce latency and significantly reduce cost. And so we're really excited about that approach and mixing in small language models as judges as well.
Yeah, small language models are getting a lot of traction lately. You said cost, latency. Also, sometimes you know exactly what the task is going to be about, and you don't need this large, wide model capability.
Yep.
And, if this model has been further trained on this specific task, could even be more accurate, right?
Yeah.
I think this large language model are doing very well on the popular benchmark, and that's the one that makes the most noise. But then, right, you have a variety of small models that can do just as well, if not better. So you developed a series of small models at Galileo. Is that correct?
Yeah. So you can read all about our viewpoints on LLM as Judge and then how we've developed these small language models, these Luna 2 models on our website, galileo.ai. We have an actual entire ebook that's just focused on LLM as Judge, taking you from 0 to 1, and then maybe even to 101, 201 on LLM as Judge. So definitely recommend checking that out if you want a big deep dive. If it's too long, you can always synthesize it into your own AI system to get the highlights. But yeah, we developed these Luna 2 models in-house. There's a couple papers we published on them. You can go to our, I think it's /galileo.ai/research for in-depth information all about our Luna 2 models. But we're really excited about them, and we're seeing a lot of success with them with major customers who we're working with, like customers like Comcast and NTT and HP and others. And as you start to introduce these small language models into different AI systems, there's just a ton of opportunities for specialization. Just like if I was building a business, right? I don't always need 100% of the brain power on something. Maybe I just need a focus specialist here. And that's why we have contractors. That's why we have subject matter experts. And I really think of our SLMs as trained subject matter experts who are on call for you in these situations. And obviously they're AIs, they're not humans in these cases. So it's great to supplement. So this is where when I see enterprises that are having a lot of success with building these systems, they have spent time on building observability. They've been using evaluations and tests in their development cycle. And then when they get to production, they are adding specialized guardrails and evaluations based off of small language models that give them really great latency, help them cut costs and let them scale. And usually they're also spot checking with human feedback from subject matter experts and or from folks who are working on the systems. And they're taking that, they're using our continuous learning through human feedback features to auto-tune metrics with those few shot examples I brought up earlier. And as you start to actually pull together those different layers of the system, you can have an extremely effective system that can solve real problems for you at scale. But getting there, we've described several different techniques, several different things. It can be challenging, So I totally recognize that if you're someone who's listening to this and you are just looking to demo an app, or you're just looking to get started, you don't have to think about all these concepts right now. You can get started with some out-of-the-box metrics. You can actually do that for free on our website. Got a free SaaS product, folks, and try it out to 5,000 traces a month. So anything that's kind of for fun or just a testing or a small application, you can try it for free. We've got hopefully good documentation. Please give us feedback. I'm sure there's plenty of gaps. And a lot of those metrics are available out of the box. Some of them we've even open sourced. So you can kind of get started there. And then over time, if you're going to actually bring this into an enterprise system, that's where you need to start looking at any of the frameworks to actually improve this to production grade and start using SLMs as judges. You can start using continuous learning through human feedback. Some of these features you can try out in the free product, but there's a huge upside to continuing to grow these systems over time. But I think really what I would encourage every developer to be thinking about, even as you're starting to demo, is just having basic observability and evals in your application for AI. Because if you want to scale it over time, you're going to want to have started to understand what's happening in the application at the very beginning. You're going to want to have these traces and logs so you can go back and say, oh, let me pull this data. Maybe you use our new MCP server for this, and you want to do it directly through your IDE, make it really easy, just pull in your API key. That's a great way to approach it. I'm not saying spend all your time if you're making a demo app on observability and evaluations, But understanding these concepts, if you are going to end up doing production AI at any point, will be extremely important. And starting to have them from the beginning, and there are plenty of free options. There's some open source metrics or some open source evals you can use as well. We may even, I don't want to promise this but we might be open sourcing a few things here in the next few months, fingers crossed. And we do have like an open source agent leaderboard where you can evaluate LLMs. So, go check that out on Hugging Face. But there is such upside in understanding these concepts. And just from a career perspective, if you are building with AI, I think getting started now and not waiting to understand how to put your evals in, not waiting to have experience here is going to put you way ahead of your competition.
Well, those are very wise words. And we know that at least 50% of people listening are not doing this.
There's lots of you. Come on.
Conor, if people want to get in touch with you on the internet, where can they find you?
Thanks for a wonderful conversation with us. It's so much fun. I'll say LinkedIn is probably your best bet. I'm very active on there. Conor Brondsdon on LinkedIn. Got a time of recording. I have about 10,000 folks here joining me there. So would love to have you join me as well. If you want deeper dives from me, I write an occasional newsletter 1 to 2 times a month at Substack. It's at conorbronsdon.substack.com, but you can find the link kind of wherever I am. I'm also semi-active on X/Twitter, and I host a regular podcast called Chain of Thought, where we interview AI experts and have deep conversations just like this one. And you can find that in your podcast feed or on YouTube. But definitely recommend LinkedIn if you want to reach out and have a conversation. And if you really want deep dives from me, the Substack's the best place to go.
Fantastic. Thank you, Conor.
Yeah, thank you. It's been a lovely time, and thanks for a deep conversation.